Hi everyone, welcome to our Energy Systems presentation. In this short informative video, we will tell you about how the potential full electrification of the automotive industry could affect British Columbia's electrical grid and the comparative emissions. The ongoing transition to electric vehicles has been seen as a great combatant to the issue of our ever-increasing carbon emissions and as a way to fight climate change while still allowing us to get around and accomplish tasks in our daily lives. However, a common criticism of this approach is that if the electricity that powers our electric vehicles does not have a clean source, then the emissions are really just being offloaded onto the electric grid, which may result in even higher emissions due to an increased energy demand. In this short presentation, we will go over the effects and consequences that transitioning to full electric transportation would have on British Columbia's grid. We hope that by the end of this presentation you will have a more thorough understanding of how the offset of greenhouse gas emissions works and is scaled based on the carbon intensity of certain energy sources. In this video, we will cover the different sources of electricity used and their relative carbon dioxide emissions, the sources of electricity used in British Columbia, BC's recent vehicular emissions, and an analysis of how the further electrification of vehicles will impact overall CO2 emissions in BC. First off, emissions from electricity generation vary by the type of energy source and by type and efficiency of electric power plants. This graph from Environment and Climate Change Canada shows Canada's emission intensities for each energy source. As you can see, the amount of CO2 produced per megajoule during any period of time will vary according to the sources of electricity supplied to the electric power grid at that time. The three major categories of energy for electricity generation are fossil fuels, nuclear energy, and renewable energy sources. Fossil fuel energy sources including oil, coal, and natural gas are non-renewable resources and are burned to produce electricity or are refined for transportation fuel. The next three graphs were derived from data provided by Canada Energy Regulator and deal with BC's electrical capacity, generation, source capacity, and source contribution. The first graph shows the shift in electrical capacity for certain energy sources in BC for 2005 and 2015. Close to 95% of BC's electricity is generated from renewable sources. Its renewable capacity exceeds 16,000 gigawatts, representing approximately 90% of the total installed capacity. Hydro remains the most important source of power generation, followed by biomass, natural gas, wind, and oil. Hydro capacity has grown by 17% since 2005 due to hydroelectric reservoirs such as Williston Lake. As seen in this graph of electrical generation, hydro remains the most important source of BC's power generation with minor contributions from biomass, natural gas, wind, and oil. Non-hydro renewable sources have undergone a 70% increase since 2005. Finally, the third graph shows the province's percentages of source capacity and source contribution for each of the renewable energy sources for 2005 and 2015. It's evident that the share of hydro in total capacity decreased from 85 to 84%, the share of wind increased from 0 to 3%, and the share of biomass remained stable at around 5%. In terms of total generation, the share of hydro decreased from 89 to 86%, share of wind increased from 0 to 2%, and the share of biomass increased from 5 to 6%. This graph uses data from the Government of British Columbia and shows the single and cumulative vehicular emissions in BC from 1990 to 2017 per type of vehicle and can be seen summed up in the red line. According to Statistics Canada, there are now more than 3.7 million vehicles registered in BC. 78,000 more were registered in 2017 compared to in 2016. Of these, 3,270 were electric vehicles. This only accounts for 0.1% of the total registered vehicles in BC. Total carbon emissions can be seen climbing to a total of 17,500 megatons of CO2 in 2017. In order to prove how the electrification of vehicles in BC will impact our overall CO2 emissions, we must look at the process from an analytical point of view. First, we determine the theoretical total energy use by converting all of BC's carbon-emitting vehicles to pure electric propulsion systems as per the U.S. Energy Information Administration's numbers of CO2 emission coefficients. Then, we study how converting to all electric vehicles will impact BC's grid demand and capacity requirement. Finally, we compare the net CO2 emissions from the increasing grid demand but lessening vehicle emissions. Here are the results. The total vehicular emissions for 2017 were categorized to different vehicle sizes and fuel types ranging from heavy-duty diesel vehicles to propane and natural gas vehicles. With the use of carbon intensity values, the total energy use was found for each category, resulting in a cumulative 256 billion megajoules. This amount of vehicular energy usage results in a 71 million megawatt-hour increase in energy demand for BC's energy grid. For context, this means that the energy grid would have to double in capacity. This capacity increase results in subsequent increase of CO2 emissions from the grid of 98.4%, effectively doubling them. However, the conversion of all vehicles in BC to electric power, paired with the increase in emissions from the doubling of the grid, still results as a 99.9% reduction in CO2 emissions. So in conclusion, the increased energy demand of the grid results in a 98% increase of CO2 emissions. However, this impact is minor due to the majority of BC's electricity generation coming from renewable sources such as wind and hydro. Therefore, the net annual CO2 emissions are reduced due to the high contribution of vehicle emissions being eliminated. This CO2 reduction could reach 99.9% annually. Currently, the biggest hurdle for this low-carbon emitting future is to meet the doubled grid capacity requirement. Thank you very much for watching. We hope that you will take away a new appreciation of BC's energy sources, as well as have learned something about the potential electrification of the province's vehicles. For more information, please visit our references.